In Unit 2, we're going to be moving away from our friend, the linear function, and our new friend's going to become the quadratic function. All functions have different forms, and so we're going to look at a number of the different forms. So forms just mean how they look. So standard form is the first form. And for our linear function, that's different than any other function. That's going to be ax plus by equals c. And that's where a, b, and c are simply numbers like 3, 4, 5. Our quadratic function, however, its standard form is going to be written with y equals, so y is by itself, and I'm going to have ax squared plus bx plus c. Again, where my letters A, B, and C just represent some number. A, B, and C may not be the same as A, B, and C here. Okay? They're just used to represent some number. So with our linear function, we're not that used to using it in this form. So usually this here, we do a little bit of math, it gets rewritten to be y equals mx plus b. So we know this as m being our slope and b being our intercept. So we call this whole thing the slope intercept form of a line. So I'm going to write that over here in form. Slope intercept form. So what we need to understand is this only happens for lines. It does not exist in our quadratic function. So over here I'm going to write does not exist. Okay? It does not exist in our quadratic function. That is only a linear thing. So now we're going to move on to something that we had studied with absolute value, and that's vertex form. So vertex form I can write that, I'm going to write that in function notation. So vertex form can be written as g of x is equal to a, and then the function f x minus h plus k. So this is just written in a, you'll see that kind of looks a little bit like what we were doing with absolute value, but I put it in function form. So when we're talking about linear, we're used to seeing y minus y1 is equal to m times x minus x1, where y1 and x1, that's a point, and where m is my slope. So this particular form is point slope form of a line. If I were going to rewrite that to be in the same format as vertex form, I would simply add y1 to both sides of my equal sign, and I would get y is equal to m times the quantity x minus x1 plus y1. So you can see these are kind of similar where x1 is my h and y1 is my k. However, a line does not have a vertex. So that means there is no vertex form. We simply use point slope form of a line. So let's make that a note. Lines do not have a vertex. So that means there is no vertex form for a line. For a line, we simply call this point slope form of a line. But it's the same sort of idea. When we look at quadratics, we can write y is equal to a x minus h, and because this is a quadratic, I have to have a square and then plus k. So you can see this is very similar to this. It should be very familiar since we've done a lot of transformations with absolute value functions. I do want to say that we can also rewrite this to be f at x is equal to a times the quantity x minus h squared plus k, because y and f at x are the same thing. So remember also that your hk, this is your vertex. It's a special xy, that's your vertex. So then the next form I want to talk to you about is something called intercept form. So we do intercept form. We understand that the intercept is referring to the x-intercept. So remember, when we're talking about the x-intercept, that means we're looking for x and y is always 0. Now, you may think, okay, I can go ahead and do intercept form of a line, but actually you can't. You can find the x-intercept, but there is no such thing. So as far as the intercept form goes, this does not exist for a line. That's not to say you can't find the x-intercept. This is just saying there is no form for a line. However, for a quadratic, there is a form. And that form I'm going to show you from, we can have x comma 0. And this means that we're looking for the 0 of the function. So that means y is 0. So at first, you may think it's this, but notice that this here is standard form. So I have to go through a process, which we'll be learning. We'll go through a process called factoring. And when we go through the process called factoring, we end up getting 0 is equal to a x minus p x minus q, where p comma 0 and q comma 0 are my zeros or my x-intercepts. So these are called zeros or x-intercepts. So the reason I bring this up is because oftentimes students get confused with thinking that form is always one thing or the other. As you can see, linear function and quadratic functions have standard forms, but only the quadratic function has a vertex form and an intercept form. Our linear function has a point-slope form of a line, and it also has a slope-intercept form of a line. So depending on what you're talking about, depends on the vocabulary that you will use.